Hello there, my sweet summer children. Welcome back to Class 5 of Unit 1, where we are going to continue chatting about equations and how we can use them to model and solve some problems that, we might find in the world around us. Now, if you can't already hear, I am a little congested. I'm feeling a little sick. Sick of you, that is, but I'm also sick of our word problems and world problems only having variables on one side. So today, let's fix that. But before we do, remember last time we were together, we came up with like a 5-step kind of strategy, game plan, checklist of things that we might want to look out for or use to our advantage when we are solving these types of problems. Look back in your notes, give yourself a minute. What are some of these things that can be helpful in orienting us, guiding us through the process of translating from words into symbols? Go ahead and see what you come up with, and we'll chat. I don't know about you, but I'm feeling a little chatty. So let's do it. Let's chat. Well, some of the things that I might want to look out for, and again, a lot of it is contextual, but like number one, if I'm working with something where a visual component might be nice, like I'm finding perimeter or area, or I know I'm working with a shape, then a diagram could be really helpful. I definitely want to make sure, regardless of the type of problem though, that I'm defining my variables, which means, right, like do I know more or less what it is that I'm trying to find and what my variable is going to stand in for. Depending on the type of problem, again, sometimes a chart might be helpful, right? Maybe there's a formula that you want to use or a relationship you know that you can take advantage of. From there, I want to make sure that my equation gets set up and solved, hopefully accurately translating from the words. And then last but not least, once I've solved that equation, I need to make sure, well, does my answer actually make sense? Like in the context of the problem, is that number looking okay? Are the units attached? Is the form that I'm stating it in line with the way that I would expect? All that jazz. So, just like the equations that we learned how to solve back in our third class, sometimes the models that we use will also need to contain variables on both sides to accurately model whatever it is the situation is that we're dealing with. So for instance, we'll start off with something like this, and then we'll get to something a little bit more grounded. So, 2 times the larger of 2 consecutive numbers is 9 less than 3 times the smaller number. And I want to find those 2 numbers. Now think again, right? This is some word salad. Oof, it's tough. Chew on it a little bit. What do you see that you can translate? Again, notice that word consecutive is appearing. How can I use it and how is it going to differ in this particular context? What do you think? Come up with something. Give yourself some time, play around with it. If you can build an equation, maybe see if you can solve it. Go ahead. And come back. I miss you. Okay. 2 times the larger of 2 consecutive numbers is 9 less than the 3 times the smaller number words. Okay. Consecutive. Do I remember what consecutive means? I hope so. Remind me, what does consecutive mean? 5, 4, 3, 2, 3, 7, 86, 1, 1/2, and stop. So, consecutive, of course, means right next to each other. But notice here I'm not dealing with consecutive odds or evens anymore. I'm dealing with just consecutive numbers, so like 2 and 3. Well, how do I get from one to the next? Well, all I need to do is add 1. So I'll say let my first number, maybe that guy is n. My second number, well, all I need to do is add 1 to that number, and I've got the next one. Cool. And now I just need to parse through this word salad and figure out what goes where. So, 2 times the larger of them. Well, the n plus 1 is bigger than the n, so that one's getting multiplied by 2. If I want to make sure that the entire n plus 1 is getting multiplied by that 2, what choice can I make here strategically to make sure that that 2 goes to all of it? Well, I can use my parenthesis, my little symbol burrito. So in this case, I've got a 2. It's going to go to the entire n plus 1. And then would you look at that? I've got an is. Well, is, of course, means is. No, I'm kidding. In this context, well, yes, it does, of course, mean is. But here it means it's an equal sign. And then I've got 9 less than 3 times the smaller number. Well, the smaller number is n. And then if I'm doing 3 times the smaller number, that's just 3 times n, which I can abbreviate as 3n. And then if I'm 9 less than that, well, 9 less than 10 is 1. How do I get there? I subtract 9. So 2 parentheses n plus 1 should be equal to 3n minus 9 here. If you've already got this equation solved, fantastic. Let's keep the video rolling. If you need a little bit more time to solve it, be my guest. Go ahead. Now, I'm assuming that everybody is here, or everybody who's here has already solved it, and if you haven't, you're a dirty, dirty liar, and I will never forgive you. So in this case, 2 parentheses n plus 1, easiest thing to do here to get rid of my parentheses. I want to put those n's together. I can't until those dirty, dirty parentheses go away. So in this case, I'll distribute my 2 to the things in my parentheses, carry down the right side, 2n plus 2 equals 3n minus 9. And from here again, I want to get all of my variables over to one side. In this case, maybe I'll move it over to the right. It doesn't really matter. But say I want to cancel out all of the n's on the left. Well, the 2n and the negative 2n here can go away. When I do that, I'm left just with 2. And then 3n minus 2n, well, that's just 1n. And the last thing between me and n by itself, nice little one-step equation. Let's add 9 to both sides. Cancel out our negative 9 on the right. And we find that 11 should equal n. And now I'm done. No, I'm not. Very good. I want both numbers. I found the first one. Well, the second one, all I need to do is add 1. So n plus 1 will be 12. And our two numbers are 11 and 12. Cool. Let's do one more to make sure that we feel really good about this. 3 times the smaller of two consecutive odd numbers, so again, we're back to consecutive odds, is 1 more than twice the larger number. Okay, you know the drill. What do you remember about the anatomy of consecutive odd numbers that you can use to your advantage? Once you've got that, how can you build an equation that accurately translates from these words into symbols? Go ahead. And stop. Okay. Well, I know if I'm working with consecutive odd numbers, again, think like 11 to 13. Well, I need to add 2 to get to the next one. So I'll say, let my first odd number be n, and then my next odd number, well, I'll add 2 to whatever that first one is. Cool. So now I'm just taking my word salad. 3 times the smaller of them, well, the smaller one is n, so 3 times would mean 3 times n, I'll abbreviate that as 3n, is, there's my equal sign, so 3n equals 1 more than twice the larger. Well, the larger one is n plus 2. Again, the 2, I'm twicing that, so I'm going to need to make sure all of it gets multiplied by 2, use my parenthesis. And then in this case, I'm 1 more than that. Well, 1 more than something just means I'm adding 1. Cool. So 3n equals 2 parentheses n plus 2 plus 1. If you've already got this, let's keep rolling. If you need a little bit more time, now's your time to pause. Okay, 3n equals 2 parentheses n plus 2 plus 1. Let's do it. So in this case, I see a parentheses. I don't like it. I want to get rid of it. So I've got 3n equals 2n distribute here, plus 4, plus 1. And immediately I should see 4 plus 1. That's something I can do. 3n equals 2n. That is, of course, 76. And then I want to get all of my n's here over to the other side. So I'll subtract my 2n's from both sides. 3n minus 2n is just n, and that means n should be 5. So our n is 5, but once again, I'm not done. I need 2 numbers, so I also need to find, well, what's the second number? Add 2 to 5. 5 and 7 should be the 2 answers to my question. Cool beans. Okay. So these are fun. So much fun. Oodles of fun. But in this case, I want something a little bit more real, a little bit more tangible, a little bit more relatable. For example, what if I'm a Florida man and I have a pet alligator and I want to ride it upstream on the Suwannee River for 6 hours? That sounds pretty relatable to me. Traveling downstream, yes, I mean, you're probably screaming if you're riding an alligator. Downstream, the current increases the alligator's speed by 5 miles per hour, allowing them to cover the same distance in 5.4 hours. So we're assuming that the alligator swims at a constant rate, and I want to find the speed of that alligator. Now, in our 5-step checklist, there is one of those 5 that we have used less frequently than others. In this case, I'm going to give you a hint. It's the 3rd one. Maybe here, some kind of chart could be helpful for me in keeping track of my information. What kind of information am I working with here? Look at all of the units. What kinds of quantities am I tracking in this problem? What are the things that I'm working with? And once you've got that, do you remember a relationship that connects all of them together? Give yourself 30 seconds. What do you see as your units, or what quantities, right? And then do you remember the relationship that joins them together? Okay, well in this case, if I look through this, I see hours. So that's a measure of time. I see miles per hour. Well, that's a measure of rate. And then I also see this word, distance. So the 3 quantities that I'm working with here are distance, rate, and time. Do you remember the relationship, the formula that connects distance, rate, and time together? Cool, well, if you don't, I'm going to tell you. If I know my rate, so like I go 5 miles in 1 hour, and then I want to figure out, well, how far did I travel in like 6 hours? Well, all I would need to do is multiply the rate that I traveled by the amount of time that I traveled at that rate, and I would get the distance that I traveled. So distance is always equal to the rate that I travel at times the amount of time that I spend traveling at that rate. This formula in this problem is our key to the kingdom. This is what's going to allow me to solve this problem. Cool. So distance is equal to rate times time. I'm going to give myself my variable. Well, what is the thing that I'm looking for? That's the speed of the alligator. Be strategic with your choice. I'm going to choose A for alligator. So let's let A equal the speed of our alligator. And then in this case, I'll give myself my unit as well. It looks like miles per hour is consistent with the rest of the problem. Okay, so now I'm going to give myself, and you don't necessarily need to, but in this case, I actually want to give myself a chart. So I'm going to give myself a little chart here. We're going to pretend that this chart looks pretty and that I can draw straight lines well. That one actually wasn't that bad. So I'm going to give myself a column for distance, a column for rate, and a column for time. And I know the relationship between them, well, distance is equal to rate times time. So I'm just going to slot that in here. I know that I have like 2 different cases where I'm measuring rate and time. What are they? Take 5 seconds. What are the 2 cases here? Why have I given myself 2 rows of this chart? Well, in this case, it's because I'm taking 2 journeys. There's one journey where I go up the river, going upstream. There's another where I go down the river, I'm going downstream. So in this case, I'm trying to slot some stuff in. Am I told what the distance is? Well, no, but there is something that I'm told about the distance. What do you see? Look at that 4th line, right? The one right before the last one. What do you notice about the distances traveled? Very nice, invisible person. Well, in this case, the distance, I don't know what it is, but it is the same. So whatever's here and whatever's here, those are going to be equal. And I know that rate times time, in both cases, going up and down will get me the distance. Well, how can I use that to my advantage here? I want to build an equation where 2 things are equal. And I know that rate times time will always get me to the same distance. Well, think back to your old properties of equality from Unit 0. What property can you use to build an equation? What can you weaponize, take, and use to your advantage here? Give yourself 10 seconds. Come up with something. Take a risk, take a chance. Who cares? What do you think you could do? Alrighty, well, in this case, I don't know what the distance is, but I do know that in both cases, rate times time will get me to the same distance. And I have a lovely property called the transitive property, which says, well, if two things are equal to the same thing, then those two things are equal to each other. So the rate times the time going upstream is going to be equal to the rate times the time going downstream. Well, what's the rate and the time going upstream? Well, upstream, the time, it takes me 6 hours to get up. Downstream, it takes me 5.4 hours to get down. The rate, if I'm going up, well, I don't have anything pushing me. All I know is that my alligator is going to be traveling at the speed that it's traveling at, so that's its rate. But when I'm going downstream, what happens to the speed of the alligator? Well, I'm told that the current increases the alligator's speed by 5 miles per hour. So whatever the speed of the alligator is, if I add 5 to that, that should account for the speed of my current. Cool. And from there, all I need to do is slot into my equation that I built. So I know A times 6, so my rate times time going up, is going to be equal to A plus 5, and then that whole thing times 5.4 going down. Cool. And now all I need to do is solve my equation. If you've made it this far, give yourself a minute, pause and see if you can find the value of A that makes this equation true. Go ahead. And stop. So A times 6, right? I can rewrite that as 6A. And then if I take on the right side, my 5.4, well, even though it's on the right of the parentheses, it's still multiplication. I can still use my distributive property. So this will become 5.4a plus 5 times 5.4. Believe me for a second here, it is 27. If you want to fact check me, do that work off to the side on your own or bust out a calculator. Who cares? It's homework. So 6a equals 5.4a plus 27. Again, my goal here, I want to get all of my a's over to one side. So let's subtract 5.4a from both sides. On the right side, they undo each other. On the left side, we get 6 minus 5.4, which is 0.6a. That's equal to 27. Well, to get a by itself, last thing I need to do is divide both sides by 0.6. And when I do that, again, feel free to bust out a calculator to fact check me. On the left side, 0.6 over 0.6 becomes 1. I'm just left with a equals, and 27 divided by 0.6 turns out to be 45. And I'm done. No, I'm not very good. What am I missing? It's not 45 dolphins. It's not 45 alligators. It's 45 miles per hour is the speed of my alligator. If you want to write this in a complete sentence, be my guest. If you want to leave it like this, be my guest. As long as you've got units, then we're happy. In this case, I created the problem to be a little silly. Like normally an alligator would not go 45 miles per hour, but we're in Florida, and Florida knows no laws, knows no rules. So in this case, 45, maybe it's reasonable. I don't know. If anybody's from Florida or has family from Florida, feel free to fact check me. Okay, one more for the road. So same idea here. In this case, I've got some cat cafes. I want to build an equation. Use what you know from before. What equivalence am I trying to establish? And how can I take what I've got in my problem as the parts of that equivalence, build an equation, and solve it? So give yourself a little bit of time. What's your variable? What two things need to be equal? What's going to slot into the equation? And how can we solve it? Go ahead. Have at it. And stop. So in this case, I have two cat cafes. The thing that I want to be equal in this case is the bill. So I want the price of both of these to be the same. My variable here, well, the thing that I'm trying to find is how long I have to stay. So here, maybe I'll choose H for hours. I could choose T for time. I could choose W for weight. Doesn't really matter. But I'm going to let H equal the number of hours, right? In this case that I'm going to need to wait. Cool. So the bill is going to be the same. So what I want is for the total price at one to be equal to the total price at the other. Well, what's going to comprise the total price? So maybe I'll put kitty cup on the left. I'll put feline diet on the right. Well, in this case, if I look at kitty cup, what's their price? Well, it's $14.99. So that's their base. Plus, I have an additional $6.50 per hour. Well, as we saw in class last time, $6.50, if I multiply, same thing as like rate and time, by the number of hours that I wait, then that should give me the total amount that I pay after those H hours. And then for my total price, again here for feline diet, it's going to be the same. $10.49 is my base price. And then I have to add, in this case, it's $8 per hour. So there's our 8H. Cool. And from here, I'm home free. Just want to get all my H's on one side, all my constants on the other, and solve for H. So let's do it. Let's move our H's. In this case, maybe I'll move it over to the right. Doesn't really matter, but the 8 is bigger. Maybe I want my variable to have a positive coefficient. So if I do that, on the left side, these guys undo each other. I'm left with $14.99 equals $10.49. And then I have 8 minus 6.50. I'm just going to think of that as 8 minus 6.5, which is 1.5. And then again here, I have $10.49. That's attached to the H. I need to get rid of it. Let's move it over to the left. Minus 10.49. On the right, they undo each other. Well, $14.99 minus $10.49. 14 minus 10 is 4. 99 minus 49 is 50. I'm just going to write that here as 0.5, right, and omit that ending 0. And then 4.5, well, that's going to be equal to, oops, sorry, this was a positive, 1.5h. Last thing I need to do is divide both sides by 1.5. Well, 1.5 into 4.5, think 15 into 45. How many times does 15 go into 45? Well, our answer is 76. Cool. So 3 equals h, that's the value of h. But am I done? No. Do I want dolphins? Do I want kitty cups? No, I want hours. So my most correct version of my answer, just need to make sure that my unit is included. We'll say 3 hours. Alrighty, my dears, congratulations. You're done. Have a lovely rest of your day. Take care, be good, get sleep, rest well, and I will see you when I see you.